So guys, let's continue from where we ended. In the first part, we looked at question 1 to 4. Now in this session, we're looking at question 5, 6, 7, and 8. Remember, I said we are going to be doing this paper in parts. Okay, so question number 5, I started doing this paper. No wonder you can see these writings. Okay, but something came up. Okay, disturbance came up. So we are now here to continue this paper. Remember to subscribe to our channel, share, give a video a like. Okay, so let's move on. So question number 5 is saying the term phototropism refers to the action made by a growth of a plant in response to. So the answer is light. Okay, phototropism is the growth response to light. Okay, phototropism is a growth response to light. Okay, now we basically have 4 types of tropic responses. So we have 1 phototropism, 2 geotropism, 3 hydrotropism, and 4 chemotropism. So phototropism is the growth response to light. Geotropism is a growth response to gravity. Hydrotropism is a growth response to water, and chemotropism is a growth response to chemicals. So now this question is seeking for us to identify a tropic response called phototropism. So phototropism is the growth response to which stimulus? So the stimulus is light. Okay, let's look at question number 6. The following diagrams show an illustration on changes of state in matter. So remember, we have 3 states of matter. We have a solid, liquid, and a gas. So why are we saying this one is a solid? Because we know in a solid, particles are closely packed. So as you can see, these particles are very close to each other. Then in a liquid, they are not very close to each other. They are just average. Then in a gas, they are far apart from each other. So this one's a gas, you have a liquid, and you have a solid. Question: which energy changes correctly occurs at 1, 2, 3, and 4? So 1. So what can help you to understand this is the arrow. So the arrow, remember, is coming from a solid going to a liquid. So 1 is a change of state from a solid to a liquid. Now when a solid changes into a liquid, that is what we call melting. So 1, this is melting, 1 melting. Okay, then 2, looking at 2 now is the opposite of melting. 2 is the opposite of melting, where now a liquid changes into a solid. The change of state from a liquid to a solid, this is now freezing. So 2 is freezing, which is also called solidification. That is the other name. Then 3, we have now the change of state from a gas to a liquid. So the change of state from a gas to a liquid is what we call condensation. That is condensation 3. Then 4, we have now the change of state from a gas to a solid, or vice versa, or solid to gas. So 4 is what we call sublimation. 4, this is sublimation. Okay, then the opposite of condensation here, can even put this one. So this one becomes evaporation. So this is evaporation. evaporation. The change of state from a liquid to a gas, evaporation. Change of state from a gas to a liquid, condensation. Solid to liquid, melting. Liquid to solid, that is freezing. Solid to gas or gas to solid, sublimation. So the answer is C. Okay. Question number 7. Calculate the weight of a 40 kg object on Earth given that acceleration due to gravity is 10 newtons per kg. Okay, so they want us to calculate the weight. Okay, so we know the formula for weight is equal to mass times gravity. That's the formula. So just say weight is equal to mass is 40 kg. So 40 times weight is 10 newtons per kg. Okay, so we're going to have remember this one is in kg. Okay, this one is in kg. So when you multiply, you're going to have our weight is equal to 40 times 10, get 400 newtons. Okay, the answer is 400 newtons. So the answer is D. Just multiply the mass given multiplied by the gravity, which is 10 newtons per kg. So when you multiply, the product becomes the weight. Okay, let's look at question number 8. The following diagrams show 4 different liquids, each of mass 10 grams. So meaning this one has 10 grams, this one has 10 grams, this one has 10 grams, this one also has 10 grams. So the mass of each of these is 10 grams, but having different volumes. So these have different volumes. Okay, now the question is which of the liquids has the highest density? So the one which has the highest density should have the lowest volume. That's the way it is. Okay, so the one which has the highest density should have the lowest volume. So in this case, we realize this one. So the answer is liquid 2. Okay, because liquid 2 has the lowest volume. Now, why am I saying the answer is liquid 2? Okay, so let's look at this. Let's try to calculate the density. So we realize in this case, let's try to calculate the density for liquid 1. So liquid 1, let's calculate the density. So you know density equals mass over volume. So density equals mass, it's 10. Volume, it's in this case the volume is 15. Okay, so we're going to have just do this. Okay, so density is equal to, and when you reduce this 5 into 10, you get 2. 5 into 15, you get 3. Okay, so density is equal to 3 into 2, it's 0. Put a point. Okay, then so we're saying this one into this is what, then you add the 0, then 3 into 26. Okay, remember to add a 0, so you're going to have like this 0.66. Okay, then let's find the density for liquid 2. Okay, so density for liquid 2, we're going to say density is equal to mass, it's what, 10. So 10 over what's the volume? The volume is 5. So density is equal to 5 into 10 is what, 2. Okay, liquid 3. So finding the density of liquid 3, we're going to say density is equal to mass, it's 10. Remember, 10. What's the volume? It's also 10. So density is equal to 10 into 10, it's 1. Okay, gram per cubic centimeter. Okay, then when you look at 4 as well, 4 we are going to say density is equal to mass, it's 10. What's the volume? The volume is also 2. Okay, density is equal to 2 into 10 is what? You get, sorry, this is 5, I mean 5, this is 5. This one, the volume is 5, so 5 into 10 gets 2. Okay, so which one has the highest density? So 2 or 4? So in this case, I chose 2. Okay, simple as that.